Hello, guys. This is Unit 3, Human Body Systems and Senses. And this is Lesson 2, the Skeletal System, Axle Bones. Here are some vocabulary words that you will hear throughout the read aloud. Axle bones are nouns. They're the bones that are located down the center or axis of a vertebrate's body. Cartilage is the strong, elastic tissue that can be found in places like the tip of the nose and the top of the ear. We talked a little bit about cartilage last unit and how a shark's bones are made of cartilage. Cranium. Cranium is the skull, the hard bones that protect the brain and give the head its shape. Cranium. Marrow is the soft tissue that is found inside bones and that is the main source of blood cells, including white blood cells. Spinal column is another name for the backbone. It's a series of vertebrae that extend from the neck to the tailbone. We've talked a lot about backbones. Structure, a form or shape, something that is made up of a number of parts arranged together. An example is the building structure was put up quickly, but carefully so it would not collapse. And then we have the word vital. Vital is an adjective. It describes something necessary for life, extremely important. What is vital? We'll find out. So what have we learned so far? We briefly heard about the skeletal system last time, along with some other systems, right? The skeletal system is made of bone, with the skeleton, right? Why is it important to the human body? Well, it's important to the human body because it supports our body, and bones protect important organs or vital organs in our bodies. Now, what is it that's called the building blocks of life? Do you remember? It's what everything is made up of, something small that you need a microscope to see. That's right, cells. Cells are the building blocks of life. All right, so far, what do we know? In the classification of animals domain, the last unit we did, you learned about a few ways in which animals are classified. One way scientists group animals is by whether or not animals have backbones. So animals with backbones are called vertebrates, and animals without backbones are called invertebrates. Humans are mammals, and so they're vertebrates. What do you remember about exoskeletons? So an exoskeleton is a hard outer shell. It's a skeleton on the outside of a body. What were some animals that we learned about that have exoskeletons? They're invertebrates, right? They're not vertebrates. We talked about beetles and other insects, crustaceans such as crabs and crayfish. Do you have an exoskeleton? No, you do not. All right, so here are some pictures that show us our different systems of the body, right? If you look at this first picture with your stomach and intestines, this is the digestive system. And then we have this next picture. This is the excretory system. It's how our body gets rid of the stuff we don't need through sweat and urine. Then this third system is the circulatory system, where your heart pumps blood through your veins and blood vessels. Then we have the respiratory system. That is how we breathe with our lungs, and we have our esophagus. And then at the bottom is what we're talking about today, our skeletal system with our skeleton. And then we'll soon talk about our muscular system with all our muscles that helps our skeleton move. And then our nervous system, which tells your body to move, right? With your brain sending messages down through your nerves. We'll learn a lot more about that. So let's get started. First, why don't you predict how many bones do you think are in a human body? And we will see if you're right. How many bones do you have? Listen carefully to find out. Hi everybody, Ricardo here. I've got a new riddle for you. We are a column of bones stacked on top of one another. Collectively, we make up your backbone. We begin with the letter V. What are we? That's right, vertebrae. Today we're going to talk about the system that gives your body its structure, allowing it to stand on its own. If you've ever seen a building being built, you know that it has a framework that gives the building its shape and keeps it from toppling over. Your body has a similar structure. Who knows what keeps your body from collapsing? That's right, your skeleton. Your skeleton is made of bones. Bones can support a lot of weight, but they did not start out that way. Before you were born, your skeleton began as cartilage, a firm, rubbery tissue like the tough gristle on a piece of meat. Touch the top of your ear. What you feel there is called cartilage. The top of your ear will always be cartilage, but much of the cartilage in your original skeleton hardened and turned to bone. By the time you were born, you had about 300 bones in your body. An adult has about 206 bones. So where did all the extra bones go? Do bones just disappear? No, they grow and change over time. Many of them join together, like those at the end of your spine called the tailbone or the bones in your skull. Have you ever heard the saying, hard as a rock? Rocks are hard due to the minerals stored inside them. The outside part of your bones becomes hard by storing minerals too. Minerals enter your body in the food you eat and the vitamins you may take. Calcium contained in dark leafy greens, broccoli, and dairy products, such as milk, is one of the important minerals that makes your bones as hard and strong as rocks on the outside. Calcium is also needed to help blood clot or thicken when you accidentally cut yourself. Without it, your blood would be too thin for you to maintain good health. At least until you reach your full height, your bones will continue to grow with you. It's hard to imagine rock-hard bones growing, isn't it? They cannot stretch or bend, so how do bones grow? Well, bones are made up of living tissue. New bone tissue is being made all the time, working to replace worn-out cells and making it possible to heal broken bones. Before you were born, your bones were solid, but many of them have become hollow over time, making them very light, yet still very strong. This is how bones differ from rocks. Rocks are solid all the way through, but bones are porous, meaning that they have many tiny holes through which liquid passes. You can see in the picture the teeny tiny holes. Marrow is a jelly-like tissue that fills these cavities of your porous bones. Bone marrow is your body's blood cell factory. It produces blood cells to fight infection and carry oxygen through your body. Remember, the circulatory system carries the blood your heart pumps throughout your body, so the skeletal system and the circulatory system are interconnected. Bones come in many shapes and sizes. Some are long and rod-like with knobby ends. Some are short and look like cubes, whereas others are flat. And some have their own unique shapes. Even though there are many different kinds and sizes of bones, all human skeletons look pretty much the same. Your skeletal bones are designed in specific ways to support and protect every part of your body. There are three groups of bones that form your axial skeleton: the spine, the skull, and the ribs. The bones that support the center of your body are called axial bones. It is also the job of the axial bones to protect the most important organs in your body. You've already learned that taxonomists classify animals in two groups, vertebrates and invertebrates. Who remembers the group in which humans are classified? Right, we're vertebrates. Vertebrates are animals with backbones. Your backbone or spine is actually more than one bone. It is a column of many bones stacked on top of one another. So you can see the picture of over here of your vertebrae stacked together. And we see something important in the middle that's protecting. Bend forward and feel along the middle of your back. Do you remember those little bones running down your back? So you may have learned in an earlier domain, these are your vertebrae, a series of bones fitted on top of another to form the spinal column or backbone. Cartilage separates each vertebrae, filling in the spaces and cushioning them from one another so they don't bang into each other. Each vertebrae has a hole in it, allowing the spinal cord, an important pathway for nerves, to pass through it. Your spinal column protects your spinal cord, in addition to providing the main support for your skeleton. Your spine is only one part of your axial skeleton. Sit up as straight and tall as you can. Now look at someone near you. Does the side profile of your neighbor's spine look straight? Probably not. Your spine is actually curved, looking more like the letter S than the letter I or the letter L. Can you think of any reasons why it might be better to have a slight curve in your back rather than a completely straight back? What do you think? If your back were as straight as a board, you wouldn't be able to bend. The shape of your spine allows much greater flexibility. You've already heard about that fabulous tailbone at the lower end of your spine. So what's at the other end? Use your hand to follow your vertebrae up your back and along your neck to your head. Feel how hard your head is. Who knows the name for the protective group of bones hidden inside your head? Right, your skull. Skull bones sit on top of your backbone, becoming the second part of your axial skeleton, that group of bones that support the center of your body. Your skull is comprised of a group of bones, 29 in all. Locked together, they protect your brain and some of your body's sensory organs. The top part of your skull, shaped like a bowl, and surrounding the brain is called the cranium. 8 thin, curved bones are tightly interlocked to form the smooth cranial helmet beneath your forehead and scalp. When you were born, these 8 bones still had gaps between them, allowing your brain to grow. Because these gaps don't close completely for about 2 years, babies have a soft spot on their heads and need very careful handling. The rest of your skull bones are facial bones, or bones in your face. Put your hand over your eyes and touch your closed lids very gently. Push up slightly towards your eyebrow. The round openings in your skull are called eye sockets. These sockets are deep enough to protect your delicate eyes. Another hole in your skull is just the right size for your nose. Though it is sometimes closed or covered up with teeth, what is the biggest opening in your face? Right, your mouth. Cover your face with your hands and open your mouth wide. Which bone moved? That's right, your jawbone. Your upper jaw is attached to the rest of your skull, but your lower jaw is hinged so that it can move up and down and side to side. Pretty amazing, isn't it? Why do you think it's important for a jaw to be able to move? Would you be able to talk if your jaw couldn't move? Probably not. Does anyone remember the 3 groups of bones that form the axial skeleton down the center of your body? The spine is one, the skull is another. The third group of axial bones is also connected to your spine. Reach behind you again and feel the bones that stretch across your back, wrapping around to the front of your body. What are these bones called? Right again, they're your ribs. Ribs are curved bones that form a protective cage called the rib cage around your heart and lungs. Ribs come in pairs. Each rib is attached to a vertebrae in the middle of your back, and the sternum or breastbone in the middle of your chest. Feel your chest. Can you count the number of ribs in your rib cage? How many did you count? You have 24 ribs, or 12 pairs in all. I just can't resist sharing a joke with you right now because it fits in so well with what you're learning. What did the rib cage say to the heart? Give up? Gotcha covered. Mwahaha. So funny. Your skull and ribs both protect vital organs that you cannot live without. However, your ribs are designed very differently from your skull. Whereas your skull is made of solid interconnected bones without spaces between, there are spaces between each of your ribs. Can anyone guess why it wouldn't work for the rib cage to be on a big solid bone? Why can't it be one big solid bone? Take a deep breath, as deep as you can. Now let the air out. What happened to your chest? Do it again, and notice how your chest goes in and out with each breath that you take. Solid bone around your chest would prevent the diaphragm and lungs from expanding properly with the air you breathe. The shape of the spine, combined with the spaces in between each pair of ribs, helps the human body structure to be flexible. Well, I'll be back tomorrow to talk more about the skeleton. Today you learned about axle bones, and tomorrow you'll hear a term that relates to another part of your skeletal system, and to your arms and legs. I'm looking forward to the next time we meet. I'll be sure to have new riddles. So you can see from his shirt what we're going to learn about next time. So were your predictions about how many bones are in your body correct? How many bones do you have in your body? You have about 206 bones. You heard in the read aloud that when you were born, you had about 300 bones in your body. What happened to the bones? Did they just disappear? Bones grow and change over time. Many of them join together, like the skull bone and the tailbone. Explain, why is the skeletal system important? Well, the bones give the human body its structure, allowing it to stand up on its own. It also protects vital organs. When you were born, were all your bones as strong as they are now? What do you think? No, they weren't. What were some of your bones made out of? Firm, rubbery tissue called cartilage, like what you have in your ear, or what a shark's bones are made out of. Compare and contrast the axis of Earth to the axle bones of the human body. What is the axis of Earth? Well, both of them run the center of something. Bones in your body are real and they support your body, whereas the axis of the Earth is an imaginary line. The Earth spins around its axis. The human body does not spin around its axle bones. Why is it important for bones to be porous? What is inside bones? Porous bones are lighter, and marrow, a jelly-like tissue, fills the cavities of the bones. Why is bone marrow important? Well, it produces blood cells that help to fight infections, carry oxygen throughout the body, and allow bones to grow. So that's why you might hear if someone has cancer in their bones, they need a bone marrow transplant. They need new marrow that's good, that can fight off the sickness. What do the bones in the spinal column protect? The spinal cord. What vital organs do the bones in the rib cage protect? The heart and the lungs. What does the skull protect? The brain, the eyes, and other sensory organs. Our word for today is structure. In the read aloud you heard, today we're going to talk about the system that gives your body its structure, allowing it to stand on its own. Say the word structure. Structure. A structure is a form or shape or something that is made up of a number of parts arranged together. A house built in an area where earthquakes are common should have a structure that will resist the force of an earthquake. In the read aloud, you heard why it is important for the body to have a strong structure. What are some other things that could not exist without a strong structure? What do you think? Different things in nature. Trees have to have a strong trunk for them to withstand storms. Different things that are built, if you're building something, have to have a structure. Okay, here's your writing for today. Compare and contrast the structure of the human body to the structure of a building. Give 2 examples of how they are similar and 2 examples of how they are different. Well, here's my example of comparing and contrasting. The structure of the human body is similar to the structure of a building. A building has beams that support it from the inside and hold it in place, similar to how the human body has a skeletal system that gives it shape and holds it in place. Another similarity is that it has walls to protect it, like the human skeletal system has a rib cage to protect its vital organs. The structures are different because the human body can bend and move while a building cannot. They are also different in that a building is not made of cells because it's not alive. That's my example. I'm sure you all did a good job too. All right. We're done for that today. So remember what you learned about the skeletal systems. I'm going to ask you during our wrap up what bones are in your axle skeleton. What are your axle bones?